So today we're going to look at a few specific problems that can come up. First one's the pendulum. The pendulum is just like a weight on a string that's going back and forth. So grandfather clock, metronome for piano, and here is my headphone. It's on a string, and all it does is just goes back and forth. And so we can measure distance and time and speed and all that stuff using a very simple object. Okay, back and forth. Okay, so pendulum has a few different things you have to be careful of. First of all, we have the swing from center. So this here is the angle. This is the swing from center. Okay. You have your rise. This here is your rise, the distance it goes up. You have your pendulum length. So length of the string is found in two different locations. Okay. Then x equals the length minus the rise. And you can use that to find either the distance, x, the length, or the rise. Normally we want to find out one of these two, the length of the rise, and so x is needed. We also have the horizontal distance, which is straight across the page. Okay? So those are the parts you need to know, and then you need to label it. What it really is it's just a very simple right triangle that you draw. That's all you need to do. Just draw a simple triangle, label your parts. So, please do that now. Draw a simple diagram and label the parts that are important. Okay. So what we're going to do is find x, and then use x to find y. Okay. So go ahead, label your HOA real quickly on your diagram to find x. So labeling your HOA, here's H, here's O, there's A. We're dealing with A and H, so it'd be cos. Equals adjacent over hypotenuse. And then you can find x using your calculator. Make sure you write down every single thing I wrote down. Oops. So 53.2448. And so then the lift would equal 65 minus 53.2448. And we are calling the lift y. Okay. So my calculator, I'm going to just kind of reverse this and go minus 65. I know the number's not supposed to be negative. So I'm not going to write down the negative because I didn't do it properly on my calculator. Okay. And so that's the answer for y. Quick little sentence. The pendulum was lifted 12 centimeters. Nice little box, done. Okay. Any questions about what I did? How we did it? Okay. Next one, a clinometer. So what a clinometer is essentially you have something to look through, and you're looking at an object. Maybe it's an airplane or a tree. Nice airplane, Mr. Barker. Or something that you're looking at, a flagpole, top of a building. And what happens is you have a weight at the bottom which moves back and forth depending on the angle of tilt, right? Depending on the angle of tilt, you'll get a big angle or a smaller angle. Now the question is, where does that angle go in your diagram? Well, let's see. The key is to put in the right spot. These actually overlap. It doesn't really look like it's overlapping. So right here, it doesn't look like it's overlapping there at all. It's completely wrong way. But here, oh, you know what? It's close to overlapping. So this angle right here is overlapping this other angle right there. Okay, and so that is the actual angle that's being measured in your diagram. It's kind of weird, isn't it? Because the guy's here at the bottom, so you think, oh, he should be measuring that angle. Well, no, it doesn't look anything like the angle that we have. This is not going to overlap the angle. Okay? It's not going to overlap it at all. It has to be completely turned around. All right? So keep that in mind that these angles here overlap. So this is 35 degrees. That's the key to getting these questions right. It says the clinometer is 1.5 meters above the ground. So the man basically is standing here at 1.5 meters high, but it's also this distance over here, 1.5 meters. What we have to do is find x, and then we can find the entire height of the tree. What will we do once we find x? Exactly, add them together. So x plus 1.5 meters. Okay, now the only other thing they give you is that the distance the man is away from the tree is 5 meters. So that goes on your triangle. So we've got 35 degrees, 5, and x. Go ahead, find x. Label your HOA, find x. Okay, so we should have been using tan. Tan 35 degrees equals opposite over x. Do your math steps, and these occur. .14, and so then the tree will equal 7.14 plus 1.5. Now in the calculator, I keep all my decimals. I don't press clear, I just go plus 1.5. And so I get 8.64. It doesn't say to round, but I'm going to round to 1 decimal. Why am I going to round to 1 decimal? Because they gave me a decimal, right? So they gave me 1, so I'm going to give them 1 back. So the tree is 8.6 meters high. Quick little sentence. There you go. Any questions? I would mark it right because I didn't specify, but on the quiz and test I always do, okay? Okay, next one. This one's a little bit of a weird question, but we want to go over it because I have seen this before. Okay? We want to find the area of each triangle. So first of all, we have to divide this polygon into triangles. Then find the area of each triangle, and then multiply by the number of triangles. Okay. So find center, it's about there, and draw your triangles. Whoops. They should all be the same, okay? Don't worry if they're a little bit off. So how many triangles did I draw? 5. So I have to figure out the top angle. If I have 360 degrees, because that's what a circle is, 360, I divide that into 5 equal parts. Each part is 72 degrees. So that's 72, this is 72, this is 72. However, in order to find the area of a triangle, I need the base of 18, but I also need the height. So you got to draw that in. Now what happens to 72 degrees? Yeah, it's split into two equal pieces, so divide it by 2, and you get 36. Okay, now we're really close. But what happens to the bottom of the base? Yeah, it divides into two equal pieces, so this is going to be 9. So what we can do now is we can find x, the height of the triangle, by using trig ratio. So now you want to find x. Go ahead. Make sure you write down all your work exactly. Do not miss anything. Be careful. $12.3874, is that correct?
Yeah.
Okay, so 12.3874. Now don't clear that number from your calculator. Okay. What we're going to do now is find the area. So the area of a triangle is base times height divided by 2. Okay. So we have to be careful here. 12.3874 divided by 2. But if I put a height of 9, what am I finding the area of? Yeah, half, the small one. That's okay to do that, but then how many small triangles are in here? 10. So I would have to have that combination. But so let's be a little more careful though, and let's use the full base of 18. And how many triangles are there of base 18? 5. So you got to be careful with this question. Now that you have that number in your calculator, multiply by the base of 18, divide by 2, times it by 5, and there's your answer. 557 meters squared. So I rounded to a whole number. It didn't say what to round to. Okay. Nope, that's volume. Yeah, that's volume. Okay. So you do have to be careful. Are the pieces easy? Yes, but the whole puzzle can be complicated. What if we didn't have a pentagon, but we had a hexagon? How many triangles would we have? 6. So we divide 360 by 6. What about an octagon? Yeah, 360 divided by 8. 8 triangles. And what about a decagon?
10.
Good. Decagons have 10 sides. So you just got to be careful on how many triangles you form to figure out that top angle. Any questions about the top angle, or the triangles, or the area of the triangle, or how many different triangles there are? Triangles of triangles of triangles? Okay, last one. So in your textbook, this is the Manitoba legislature. Okay, so it's the Manitoba legislature building. So when it comes to that question, you just want to draw something similar. Okay, so all you want to do is draw the diagram and then label it properly. Okay, so for the Manitoba legislature building, just practice it in the margin, drawing that. Okay, so you can label it properly, because they don't give it to you and it's kind of hard. Right. So what we're going to do then is we have a 90-foot observation tower. Here we have 2 triangles. They share 90. You want to know the distance between the fire and the tower. So you have to find x here and y over there. Then you have to find the distance between them, w. So what are we going to probably do to find w, keeping in mind that this is a right triangle along the ground? Pythagoras. Okay. The trick is, how do you get inside your triangle? Because right now, 2 degrees is not in the triangle, it's outside of it. So what can we do to get in? You could do a mere triangle, totally could. Or you could subtract from 90. And so this would be 88 degrees, and this here would be 85 degrees. Or, remember the 2 degrees up top is like 2 degrees down below. Which method would you guys like me to show you? 88, 85? Okay, let's do that, because we haven't done that method yet. Okay? So find x and y using 88 up top inside the triangle and 85 up top inside the other triangle. So it's 2 separate questions. Go. So on the right triangle will be tan 88 degrees equals opposite x over adjacent 90. Okay, the 90 is shared with both of them. Okay, so then you could find x, and you're going to do a very similar, very similar thing to find y. Okay, go ahead, try those. Now I'm going to have trouble keeping this number on my calculator, so I'm going to keep 5 decimals. Okay. Then to find y, you would use tan 85 degrees equals y over 90. Very similar. Does people get that? 1028? Now it's easy to keep that on my calculator because I already have it there. So then to figure out w squared, would we add or subtract? Add, because w is our hypotenuse. It's got to be the largest. So on the calculator, I already have this number. I'm going to square it. And then we're going to add the other number squared. So if you know your quick little squared shortcut, it makes it easier. And so you should get a very large number, 7700516. 0.86. Again, I don't want to get rid of my decimals. I want to try and keep it as accurate as possible. And then just square root that. Oh, I think my computer's going to shut down here. Very good. Okay. So since it's already on my calculator, I can go square root or square root A and S. Remember that answer button? So I get 2774.98. And this is to the nearest foot, so we can say the fires are 2775 feet apart. Okay, which is over a mile. A mile 1600, isn't it? Not sure. Okay, so this is a good question. It's very, the pieces are easy, but to put the whole thing together is complicated. For your homework for today, I have changed it. All I want you to do is page 118, numbers 6, 8, 9, 10, 11, 12. 12 is the legislature building, so give it a good shot. You should be able to get it, but if in doubt, just keep going on, okay? And then the worksheet, Trig Apps 2. All I want you to do is 3 questions. Numbers 9, 12, and 13. 13 you might need help drawing, but give it a good shot. Okay? I've reduced your homework by a lot, and what was on the sheet was too much. But you guys need to respond and be working for the next 25 minutes. Start on the textbook work first. It's the easiest stuff. There's diagrams given to you. That's where you should start.